In this short video, I'm going to solve this problem, which is a problem on introductory kinematics. A particle moves in the xy plane so that its coordinates at time t seconds are given by x of t equals to r times omega t minus sine omega t and y of t equals to r times 1 minus cosine omega t. What is the angle between the velocity and acceleration vectors of this particle at t equals to 4 seconds? Pause the video at this point and give it a try yourself. If you do the calculations correctly, the answer that you will get is 2 omega. Okay, let us determine the velocity and acceleration vectors at a given time t. The vector v of t is equal to x dot of t and y dot of t. So the derivative of x with respect to t is r omega minus omega cosine omega t, and the derivative of y with respect to t is r omega sine omega t. For simplicity, I can factor r omega out, and then I will have 1 minus cosine omega t and sine omega t. This is the velocity vector at time t. If I want to find the acceleration vector, I have to differentiate the velocity vector once more with respect to time. Our omega is a constant. Here it becomes omega sine omega t, the derivative of the first component with respect to time, and omega cosine omega t, the derivative of the second component with respect to time. Again, I factor omega out, so it becomes sine omega t cosine omega t. Now let theta of t be the angle between the velocity vector and the acceleration vector at time t. You know from vector algebra that cosine of this angle is a dot v divided by norm of a, norm of v. Okay, so the dot product between the vectors a and v are simple. I just multiply the x components plus multiplication of the r components. Of course, we have also these factors, so it becomes r squared omega cubed, and then I will have sine omega t times 1 minus cosine omega t plus sine omega t times cosine omega t. So I multiply the first component by the first component, the second component by the second component, and I add them up. And now the norm of this vector is just r omega square root of the first component squared plus the second component squared multiplied by norm of this vector is that constant r omega squared, and then I have square root of the first component squared sine squared omega t, second component squared cosine omega t. Okay, but now look here, this multiplied by that, it becomes exactly this combination, so those are cancelled. This is just simply 1, and if I multiply this in, I will get a minus sine omega t cosine omega t, which will cancel that one, so I am only left with sine omega t in the numerator. So this becomes sine omega t in the denominator. I open up this part, so it becomes square root of the first one squared minus 2 times the first one times the second one plus the second one squared, and then of course at the end I have also sine omega t squared. Yes, but now you see what happens. This is just simply 1, and this one and that one is 2, so I factor a 2 out. So it becomes sine omega t over square root of 2 times 1 minus cosine omega t. But we know that this has a formula. This is just 2 sine squared of omega t over 2. But then this 2 and that 2 becomes 4. Square root of 4 is simply 2. So the numerator, I also use the double angle formula for sine, and I write it as sine omega t over 2 cosine omega t over 2 divided by 2 sine omega t over 2. And now what happens here, this and that are cancelled, this one and that one are also cancelled. So what I get cosine omega t over 2. So what did I get? I get cosine theta of t equals to cosine omega t over 2. So this means that theta of t is omega t over 2. But now t is 4 seconds, so this means theta at 4 is equal to 2 omega. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.